Hello, Roger. Hello, Amir. How your day is going?
Good.
Okay. Nice to hear. So is there a lot of stress by the end of semester, or it feels easier?
Very stressful.
Ah, I'm sorry if this course adds stress. The the only comfort that may be for some of you, it will be contribution to the future research.
Yeah. Nice time.
Okay, so I do have two items in the plan that I hope to complete, and one optional. Um, um, so the first one, I will briefly show one more skill, which will be primarily an answer to the question by Raju. So it is the file that has been attached to the email sent like a minute ago. And I hope it will take maybe 15 minutes, maybe a little longer. And then a second point, I will make one-to-one interview. We all will stay in connection, but I will visit directories of each class member and check the directories and ask if there are any questions that need immediate quick fix. And after that, if time allows, I will show one more skill which is not critical to the success of the project, but could be helpful, especially to those who is interested in charge transfer and who is already suffering complicated analysis of multiple orbitals. So the while I'm speaking and showing something on the screen, please consider to open three terminal windows, one on the local computer, one on the photon, and one on the NERSC, so that we will be transferring files and we will be ready to transfer files. So I am going to share screen and first bring up the document that has been sent to no, not this one, that has been brought up to all of you by email. So do you have an idea what is shown on this diagram?
Yeah, I have the
Can you please explain? And it's very nice of you to tell about it because it's primarily your question. So
actually this is the distance covered by the ion. Uh, Actually, it is how much it um, how much it goes when it moves between two atoms. Actually, for a distance.
I
hear. About interaction between atoms, I think it's a different thing to argue.
Amir, can you repeat your?
Yeah, Tamil, can you please? I'm not sure, but this is radial distribution function. So this is a plot. If for instance we have several particles in the space, it could be everything, orbital, particle, everything, and we measure the density for each radius. For different radius, we can plot this distribution for that several spatial position of that point. and then plot the distribution for different radius or different distances. I'm not sure if it's correct or not.
Yeah, it does make sense. So I will show how to get this figure, and I was using files in Raju directory. But so I'm going to scroll. There are some examples from previous year, and the.
But this is actually so far from the paper I see they has discussed about this thing. They mentioned this about like the distance covered by an atom.
Raju, please repeat your sentence once again.
They have they mentioned this figure as the distance covered by atom.
Not quite. I will explain. Just wait a little.
Okay.
The distance from the atom that we want to get that radial distribution from, regarding the other atoms that are close to it, or the other particles that are close to it.
Yeah, it is better. Yeah. It is better. It is. So here is the equation, and you see here we are running summation. We are running summation over all possible pairs of atoms, and then we subtract. We measure distances between atom number I and atom number j, right? And then if this distance is equal to trial distance that we want to put in the function, then there will be a peak spike, so like delta function as we did before. And there is also normalization so that it doesn't get too tall, because the space is three-dimensional. There is a Wikipedia page, and this is not bad. I actually like how it explains. So what they show that well, it can be not everything. It's not ideal, but it's a good starting point. So if we do have a pink atom and blue atom in the model, then we can say what is their distance. But then we scroll through all atoms in the model and select all pairs. So we just pink means index I, blue means index j, and then we compare all possible pairs and why this observable is needed. Like if you think that it is not quite important to you, just focus on your project, but for some of the projects this will be an important thing. So this radial distribution function is a measure of crystallinity. If the material that you are modeling is pure crystal, then this radial distribution function will have peaks at distances corresponding to interatomic bond length. If at the argument smaller than interatomic bond length, this function is 0, because atoms cannot be squeezed too close to each other. If one takes argument further, then it will show another peak corresponding to second neighbor. Like in crystal lattice, there is a second neighbor, third neighbor. If the model is experiencing phase transition from crystal to liquid or to the gas, then these peaks first become broader and then completely smear out into very homogeneous distribution. So if your model upon heating and molecular dynamics becomes amorphous or melts into liquid, then this radial distribution function can be a good measure of this melting process. Why it is needed? Of course, making movie of molecular dynamics is better than anything. I love movies. But if your model has more than 100 atoms and you need to do it again and again, human brains can be exhausted with too much graphical information. So this radial distribution function projects three-dimensional crystal or three-dimensional liquid or three-dimensional gas onto one function. And it is not design of your humble servant. It is not specific tool to like make life of students taking this course uncomfortable. It is a very standard tool that is often measured through neutron diffraction, and it is a standard tool to characterize melting or phase transition processes. So let's just briefly discuss, are there any questions in principle about this function? Okay, if no, let me come back into the skills. So on the NERSC there is a little list of tools needed to do it. So it's just like a little help, and I was checking that it does work and updating it like an hour before the meeting, and I'm going to repeat it once again. So this procedure will be, it is not mandatory. It is only optional to those of you who anticipate that your model is has some crystalline properties, and during molecular dynamics it may lose these crystalline properties, like it experiences glass transition in polymers, or if it is chemical reaction and it breaks several bonds, then these peaks in radial distribution function will become smoother. So it is reasonable too. So first, yes, and I will show it step by step. I just want to give heads up. So first I'm going to the directory where all tools to process VASP are located, and use standard script that is used to convert VASP format into XYZ. So after running this command, there is a quantcar.xyz composed. Then I do create the file input RDF that this first number is how fine is our grid points, like if how fine this grid points. And here is how many angstrom, the range for this. Yes, Raju, please ask.
So the grid point is 0.1. What is the
in angstrom, how fine the let me come to the diagram. So two nearest points in this continuous line are offset by 0.1 angstrom, and the whole figure is created for the range from 0 to 15 angstrom. If one looks onto standardized radio distribution function in Wikipedia, then after some period it comes to continuous and it constant, because it becomes almost random for distances. And since size of the model is finite, there is no, like, if your model is 30, or like if your model is 10 angstrom, there is no reason to explore distances more than the cell size, because all atoms are inside the cell.
Yeah.
Okay. Well, the script that we will use cannot look outside of the periodic unit.
Yeah.
So we look. So this little script is needed to use GNU programs compiled before. We used the same line for making oscillator strengths. And this little code reads contcar.xyz and creates file named CR that includes the X. First column includes the offset little r parameter, which is on the x-axis, and then second and third lines are normalized and non-normalized radio distribution function. If I'm going to scroll a little bit to the equation. So normalized is when we have this factor 1 over PR squared, and non-normalized if we remove this factor. I'm going back. So after running this script, a file CR with 3 columns appears, and then I'm launching the GNU plot with a specific script that creates a file rdf.ps, and then we convert it into PDF and transfer it to Photon, and from the then on the local computer we pull it from the Photon to local computer, and then one can plot it and see. So the shortest distance is 2 angstrom, and then there are some peaks. Make sense?
Yes. Can you please repeat again about the 3 columns?
So first column is parameter r, distance, lowercase r. The second column is delta r minus ri minus rj, and the third column is 1 over 4 p r lowercase squared delta. Okay.
Hi, Dr. Kelly. May
Yes.
I have a question?
Please.
There are different types of atoms in the system, so we just consider all the atoms or some specific atoms.
Oh, I I like very much your question. So this script takes all atoms, but if you want to measure partial radio distribution function, for example, between only oxygens. I think not everyone has microphones off. I suggest we should switch turn microphones off if we are not speaking. If you need partial radial distribution function, for example, for oxygens only, you take this concar.xyz file and remove all elements and keep only elements with oxygens, and then run this script. We were trying to make a universal code, but then it becomes too many difficulties. Modifying input file is much simpler, and then it's kind of universal. Make sense?
Yes. And another one question. If you look at the radial, what's the name? The radial distribution function curve. Yes. And finally it converges to 0. When you look at the curve in the Wikipedia, it converts to 1.
Yes. Yes.
Yeah.
I like your question as this question as well. So if this script does not take into account periodic conditions. So if on the argument bigger than half of the cell, the results do not make sense. So one always needs to select X range smaller than half of the cell, then it will make sense. Because it will, if it takes size of the cell or size of the cell times 1.4, it may take atoms from opposite corners, and there will be very few such atoms. And if you take distance bigger than maximal elongation along the cell, there will be no atoms, right? And there is no reason in this long distance correlation, because most interesting properties are happening only on first 4 or 5 angstroms. Okay?
Okay, so the first peak corresponds to the bond distance?
Yes, shortest bond distance. And this is, I think our lives are already hard. We do not need to overdo things. But if in addition to standard procedures for research, you want to characterize geometry of your model before and after heating, you may generate this RDF before and after and see how much it changes. So I'm going to quickly repeat this protocol if you want, or I can probably it's better if I show that it works, and then I will go one by one into directories of each class attendee and make a little interview and check how happy or unhappy you are, and offer help if needed. Is this plan accepted?
Yes.
Okay, thank you.
Yeah, I believe I have a question on the RDF graph. I understand if the crystal structure, then the distance between peaks would be the same, right? It would be kind of periodic, right? Like the distance between the peaks should be the same. The height of each. What about like when is it like the density? Does that mean there is a lot of atoms? For example, the first peak, does that mean that there is a lot of atoms that are close to the first atom?
Okay, Salim, I'm going to draw something for to answer your question. So suppose we have regular cubic lattice with maybe atoms of only one type, and let it be two-dimensional. Then the first peak would correspond to the shorter interatomic distance. Yes?
So this atom can bond with other atom, am I right?
Raju, I need to answer to Salim first. And radial distribution function does not refer to presence or absence of the bond. It just shows correlation between interatomic distances. Make sense? Right? So I'm continuing to answer to Salim's question. So this black line would give a peak at the interatomic distance. Now I'm exploring the distances from this, let's say, first atom. So if I'm looking on the larger distances, so the next one to the atom number maybe 4, this will be square root of 2 times R naught.
I see. So it doesn't have, it's not going to be this. It's not going to be the same distance, but only the first. Yeah, the first bit is the nearest neighbors.
Yes, and when we look onto next layer, then this one will be like 2. And then one place the geometry, and there will be several peaks, and one can compute what these peaks are. But detailed analysis of this function far away from the origin is not very useful. The main importance is to assess how broad these peaks are. So if they are narrow, it means all atoms keep the same crystalline structure. But if atoms start, like this pair of atoms is close to each other, and this atom departs a little further, then the peak gets broader. And if a structure gets amorphous, it becomes less structure. Make sense?
And what about the height of each peak axis?
There is the larger the number of atoms, the higher the peak. But we are putting the normalization factor divided by 4 pi r squared that should compensate like the growth of the number of atoms, and try to normalize the heights, so that for the systems with different number of atoms, the heights will be the same.
Okay. That makes sense.
Okay, yeah, thank you.
That makes sense, yes.
So I'm going to quickly go over the scripts. Well, I can go into directory of any other project if needed, or I can repeat it here. So suppose if I remove concar.xyz, and I want to recreate it once again, module show wasp. So this command gives the subdirectory where the scripts are located. I'm pasting it and doing position to xyz.pl concar. And after the script, this it does create this concar xyz, and other files are appearing because I think there is still job running in this directory. So after this concar.xyz is created, yes.
Because their job is running, still running. So if you please go to the relux.
It doesn't matter. The wasp saves concar file at each step of molecular dynamics.
Yeah.
So it will be one of the intermediates, and I'm not generating final results for your project. I'm just illustrating the protocol.
Yeah. Yes. Yes.
Okay.
Okay then.
So next step, I'm creating the input RDF, and I can put smaller number here to avoid this escape right quit, to avoid decline of the function to 0. Now just a second. I think we need to bring this command. So right now this command is not needed because I already did it. So right now probably you do not care it, but there are libraries for different compilers, and GNU is free compiler, and this Intel is commercial compiler, and I'm just replacing libraries. Let's add this line into RDF. Okay, so and now I can do the bin pair distribution version 8. So it gives me some error. Let me check what is why it is not happy. So I did remove the text in the second line, and I'm going to the last line and adding the empty lines just in case. Okay, let's check. Now it works. Probably the script hasn't been taught to read text input, so it runs without error. And when I look onto the recently created file, it does have this CR. This file includes radial distribution function, where first column corresponds ranges different values of distances, and second and third are normalized and not normalized radial distribution function. The next step would be to make plot binary GNU prog RDF, let's say 4. Okay, it works. And just in case, you can make a copy of this script and modify it. If you look inside the script, so it sets output file, and then it tells plot CR using first and second. And for the second panel, it plots CR using first and last lines. So after this has been created, I'm typing, converting PS to PDF WR RDF. Oh, let's check if this RDF has been created. It is requested to create RDF.ps. And it did create this RDF.ps. Now if we type ps to PDF write RDF.ps, it has created this RDF.pdf. And after that, I'm going to copy all files with extension PDF to this proxy server, and then I'm looking for the class directory, the individual, and then browsing to the directory that would correspond to this thing. So after that, I'm going to the local PC. So I'm renaming the old version, and then copying this RDF.pdf from the proxy server, from the Scratch directory, start.pdf, everything into here. And after that, I can, so this was previous one, and I'm going to open the one that was just recently updated. This one. Open. So the first, it has two pages. This document has 2 pages. So the first page, it is not normalized. It's just implementing these delta functions, and you see as argument grows, we have more and more bonds, and therefore function grows. So it grows. It will grow quadratically in the infinite model, because surface area of a sphere grows quadratically with radius. And if you go to the second normalized, it is divided by this growing sphere, and then it approximately approaches to 1. And the first distance in this model will be approximately 2 angstrom. So this implementation has less questions, so we set up the range of exploration smaller than cell size, and it matches expected trends that at larger arguments it is approximately 1 if normalization is practiced. Let me check if there are specific questions about this skill. And if there are no questions, I will go one to one through the directories. Probably we should go with members of the class who are in the undergraduate program first, and then going to graduate students second. And if there will be time left, I may show how to special way how to represent the partial charge densities in the compact way, but it is not a key information. This is secondary thing. Okay, so since while we are speaking one-to-one, the rest of the class is invited just to keep working on the projects. The general idea is to have directories optimized, another directory for heating, another for molecular dynamics, and the fourth for properties after molecular dynamics is complete, single point, and in first and last do density of states, spectra, and orbitals, right? Okay, so I will talk first to Rebecca and then to Steven. So Rebecca, do you have microphone and maybe camera?
Just give me 1 second. Does it work?
No. Right now it is not so critical. I think the voice connection is fine, but when we will be doing final presentations, please, everyone, please make sure that your cameras are working. It will be easier for to follow the presentation if the speaker is visualized. And I will explore if you can do it in Zoom. Maybe it will be a little better quality. So Rebecca, let me check your. Let me just take a little interview. So how do you see your project right now?
I want to focus on the gold.
Okay.
If that is okay.
Oh yes. Oh yes. The gold is okay, and I am. I was always thinking that again, your voice is most important, but in your project for research, you are using probably 1 gold atom, right?
Yes.
And you are using confined systems. What could be, I'm offering you, you are free to accept or decline. What you could do in this project for the gold is to take cluster of gold and use graphene in VASP with periodic boundary conditions.
Okay.
So let me bring to your attention several directories where I have preliminary results. CT project. I'll probably do. I'll do a little file and with list of directories. It will be quicker. Insert. Okay, so I am S minus LT grep LAB14. So before we go to technical details, let me bring the motivation. Why periodic boundary conditions are better than flakes? Would you agree that periodic boundary conditions and infinite graphene is better than flakes?
Yeah, because it is closer to the reality.
Okay, good. Okay, okay. I had a fear that you will start arguing, but if you are on the same page, it is good. Now, why gold cluster is better than single atom? Or would you agree that cluster is better than single atom?
Yeah, I think that is what we want to look at the end. Like,
okay,
we want to have the gold cluster grow from the gold atom.
Mm-hmm. Okay, okay, very good. So right now we need to be quick, so I'll share with you pathways to all these directories. So they all have the same size of the hole and slightly different, the same gold cluster, but slightly different surface termination of the edges. And
okay,
you can quickly look inside, or we can exchange emails and maybe select only one of those that seems most reasonable to you. So I will quickly create a list of this directories so that you can browse through them.
Thank you.
Oh, not a problem. It's my pleasure. And most of them are pre-optimized. So oh, I know I will do it very efficiently, I hope. VI directory. No. Direct. Okay, so it will be in your directory, and I will put. I will fill this file with It is something that I'm not doing every day, just sharing big number of directories. But I think we'll do it. We'll do it very quick.
Yeah, but thank you. I appreciate that.
Oh, not a problem. Not a problem. I apologize for having too many models, and for the class there is no chance to do all of them. So you in addition to standard work, you need to scroll through them and select the best one. But I will be happy to contribute, and we'll exchange emails which one to use. So PW. Okay. Now let's go to the third. Fourth. So while I'm doing it, let me keep talking. I will be not as good speaker in parallel, but all these models have smallest gold cluster of 13 atoms. And the gold 13 has the best optical properties when its oxidation state is 5+. So
sorry, what did you say?
For the gold, if one takes a cluster of gold 13, right? If one explores it in the oxidation state 5+, it has the best optical properties. It has open gap. It's most comfortable configuration for this cluster. So and when one surrounds it with carboxylic groups, deprotonated, these carboxylic groups have one minus, and by having like 5 carboxylic groups, it will bring it to 5+, and it will be more stable. It is just a factor to take into account. So I'll continue my little journey through the directories. So we did 6 directories. Now do number 7. See. Directory 7. And I think this one is the last one. The other directories here are on the silicon substrate, which experimental groups do not support.
Okay, thank you
Uh-huh.
very much.
Oh, I'm almost done. Okay. Let's look if this. Yeah, it was working. And then I know that what I'm doing should be more efficient by writing a little script, but for just a couple of records, this will be probably quicker. Okay, so you have directories that you can just make cd into this directory and explore it, and feel free to copy the whole directory or the one that you want into your into subdirectory for your project, because it will be if you need any help, it will be so much more organized and easier for me to go to this directory and help.
Okay, thank you so much.
So, do we have any other questions to discuss? Do not hesitate. How do you? What is your vision of the research steps for the project? What do you plan to do?
So first, I would choose a model,
Mm-hmm.
and that now that it's pre-optimized, I have to optimize it again. I mean,
Okay.
I could, right?
Okay. And after it is optimized, you can do the density of states and spectrum, right?
Oh yeah. I mean, yeah. And then the heating, or is the model too big for that?
Pardon me?
The heating with
No, these models are very small for VASP and for this cluster. For NERSC, it is nothing. They will hit and run molecular dynamics instantly.
Okay, so I can.
Yes, you can hit and run molecular dynamics easily. This will be not a problem. And if the jobs that you are submitting are not working as you expect, if there are any delays, send me an email immediately. I will take care of it. I certify that all these models are small, and it will and it should work very, very quick.
Okay, and when I have the gold 13 5 plus, should I use spin polarization?
Oh yes, excellent question, and it is a very, very good plan. So I cannot demand it because it will be too many things. But let me insert new slide. Let me. I'm going to bring empty PowerPoint slide and just quickly scratch something there, and I will put TOP to prevent random. So the model, one can modify the number of atoms by typing number of electrons, right?
Yes.
So first you explore from your optimization job what is natural number, and then you add or subtract couple of electrons from the system. If you want to do it, then for each run with modified number of electrons, one needs new directory.
Okay.
And please be careful in the following sense. Right now, when I'm giving some suggestions, I can be too much enthusiastic and suggest too many things. You need to judge your own schedule and time you can invest, so that you do not make too much tasks for yourself. Do maybe lesser things that you can accomplish to and finish in a reasonable time. When we will be done talking one-to-one to you in this session, if you stay for another 15 minutes and listen to conversation with Steven, you may get some additional ideas, because for him, scanning of this number of electrons is a key part of his research.
Okay.
Okay. There is another thing that I can bring to your attention, but again, I cannot judge your schedule, and this is maybe too many ideas for immediate implementing. So suppose you have I have a models, but I don't have time to copy them right here. So suppose we have this hole in graphene. We do have a gold particle here, and for the experiment that computation is trying to help, the main idea is to check what would happen to electronic structure if one adds SH2 to the surface. So if one brings one or maybe many of such molecules to surface of the gold, they attach, they form a strong coordination with gold atoms, and they are expected, like if you do have density of states. So this SH2 is expected to contribute new states inside the gap. And
Okay.
if looking onto absorption spectrum, then like standard absorption spectrum has some features, and SH2 is expected to bring a feature near zero frequency. So again, please be please be a director of your own project, and plan your efforts so that it doesn't take more than, I don't know, 3 hours of your time, and more than I don't know, a week of computer time. But this could be an observations directly related to experiment.
Okay, so I have a quick question.
Please do.
Would I compute that, like, I use one of your models and then just add the SH2 to, like, close to the gold cluster?
Yes, if you want to do so, and then it will be, if you do it before optimization and you optimize, it will set on the surface of a gold instantaneously. It has very good binding energy.
Okay, that makes sense. Okay, thank you.
Okay, are we done?
I'm good.
Okay.
Thanks.
Okay, yep. And I will be checking emails regularly. Feel free to ask questions anytime.
Thank you.
Thank you, my pleasure. Steven? Are you connected?
Yes.
Okay, so let me go to your directory. So, would you please explain your vision of your project?
So, what I was, my understanding of what the project would entail would be that now that we have these three models of different oxidation states of this catalyst, we can do simulations of different oxidation states of the central ruthenium atom to determine which is the most stable oxidation state for each oxidation formation, the hydroxide, and the oxide.
Okay. So let me. I agree with you, and let me type it in here. So there are three models that the same complex is connected to H2O, OH, and oxygen, and then for each of the models we can build directories with number with like oxidation 0, 1 plus, 2 plus, 3 plus, 4 plus, and 5 plus. I think this will be more than enough. And then it will be total like 18 directories, right?
Yes.
And then in each of the directories one can run optimization, hopefully complete, but if since time is limited, even if it is partial optimization, it will be interesting. And then for each of this cell one can put their total energy, the one that comes at the end of the OSI car, like F equals and then the number. And as soon as such table is ready, we should consult. Please send me an email immediately, and I suggest that we select a champion with minimal energy in each of them, and then we will process molecular dynamics with champion only, because otherwise it will be too many models. So how do you see, and to my memory, it was for ruthenium complex, it is expected that more stable oxidation given minimum of energy is either 2 plus or 3 plus, but for this hydroxyl it was in the 1 plus.
That was the HY directory.
Which one?
The one that you said is the most stable in 1 plus. That was the RULGHY.
Uh-huh. Yes.
That's the
the water molecule addition, not the hydroxide.
Okay, water molecule. Okay. Cation 1, it will be number of electrons 157. Tail minus N1 OZ-car. Edit, copy. No. So for water, likely we will pursue heating and molecular dynamics for this one. But I wonder what would be the champions for other structures and other electronic configurations. Steven, what do you see major challenge in your activity for the project right now?
Just scheduling time to work on it, really, and
okay,
interpreting commands.
Okay, so let me suggest to do quick practical activity. So since this one's supposedly is the champion for the water, let's do make directory heat. Copy. I would just do everything into heat. And copy binary in-car heat here. So it is important that I will borrow from original in-car this records iSpin2 and number of electrons 157, and then copy in-car into in-car old, and now copy in-car heat into in-car vi in-car. So now this one sets up heating. 300 Kelvin is realistic, but it is boring. Let's do it at least 600 so that it will be more vivid dynamics. I know it is not very realistic, but otherwise it will be one wouldn't see too much differences. And what mandatory, one needs to paste there this iSpin2 and number of electrons. Otherwise, it will come back to the neutral. Now I'm copying from cont car into pos car. .sh. So I'm copying query debug into query regular sh. And let's put a little bigger time, like 6 hours, and put more resources. and submit it. Oh, I have forgotten to make the main change. Instead of debug, it should be regular here. Okay, so at least this thing is going on, and returning back to this table, do you have an idea how to run, how to create directories and run this stuff for OH and O?
I think so.
Okay, let's probably start doing them. Right now, I probably need to focus on other projects, but let's do maybe just beginning together. So we were in the HY. Let's go to OX. So grep number of electrons out car. So it has the number of electrons is 156. So I'm going to make directories. Make directory number of electrons 156, and it will be either I can call it neutral or cation 0. Directory. And then by subtracting, if I subtract 1 electron, 155 will be cation 1, cation 2, cation 3, cation, oh no, bad name. Cation 5. So the directories are there, and we need to copy postcard into each of them. And do the same for the input files. So right now I'm going to copy this template in car into each of the directories, but there one would need to individually modify okay. And in order to VASP to run, one also needs to copy their key points. And one also needs to copy the podcast. What else is missed? I think one is missing the input files, the .sh files for running for submission of scripts, right? No such file directory. What does it mean? Okay, it works. So just copying the okay. So we do have directories for different level of oxidation, right? Steven?
Yes.
Okay, so and I think I will complete this stuff, but then you will probably do the same for the OH group. So, and now I'm going one by one to this directories, opening the imcar, and if we are in cation 5, we need to so I'm removing electrons, and after removing electrons, I'm doing as batch query debug. Now going to number of electrons cation 4 vi incur. So here it is 152 electrons to have a cation 4, and I'm doing as batch query debug. So did you get the protocol?
Yes, I think so.
Okay, so please okay, I'll probably submit SQS debug. Just submit a couple more, and then you do the one for the hydroxyl. So I'll go to 3. Okay. Do you have more? Do you have questions about your project? Do you see something that we need to discuss right now?
No, not right now.
Okay. So and please send me requests for help as soon as you realize. The sooner the better. As we approach to the end of semester, maybe your schedule is getting more busy and mine is getting more relaxed, so I will have time to look into and to check what is going on. Okay, then with your permission, we declare completed one-to-one session, and I'll go to the next class attendee. Okay. Oh. I think the next will be Mahek, and after her, next will be Salim. Mahek? Are you online and does your microphone work? I do not hear. I do not hear.
I think she leave a message.
Oh, okay, okay.
Our microphone is not working. Sorry.
What is not working?
Microphone.
Microphone?
Yeah.
Your microphone or microphone for Mahek?
She is going to reconnect.
Okay, okay.
Can you hear me now?
Oh, yes, I can. Yes, I can. So let me go to your directory on this NERSC server and check which files are ready and which needs further.
Dr. Dimitri?
Yes?
I'm unable to view my file on JMOL. It's showing me an empty file. It's test.xyz.
Okay, so you are on the photon, right?
Yes.
Okay. I'm going to photon. Oh, it did disconnect me. So which file should I look at?
Test.xyz.
How did you create it?
The way that you showed me, I copied the Gauss view file to test.xyz, the other one, not the capital letter one. Test.
So
Yeah.
your the file test.com is your original file, right?
No. My original file is phospholipidfinal.com.
Okay. Okay, let's do let's quickly look when it goes here first and then process it. So you didn't add the peroxide to the model?
I did. It's the oxidized model.
Oh, okay. You're considering oxidized model. Okay, good.
Yes.
File, save. Let's save it as PDB. Okay. PDB. XYZ. Okay, this is a good XYZ file. Let's do it. Sort. You're following what I'm doing, right?
Yes.
So I'm looking inside and checking the second line should be empty, and then going through file and double checking that there is no random garbage or text file. Okay, so this text at the end is not needed. Escape, wait, quit. Rotate. Sync to wasp. First I'm just trying, it works, and now since you are not wishing to do periodic like a crystal, you're doing only a single molecule, let's do maybe 6 or 7, like a little bit vacuum. Now pwd, here is the edit copy, here is the directory. Now I'm going to the nurse and maybe make directory oxidized as you monomer. Go into this oxidized monomer, SCP, and then pasting the path and .xyz. into here. Oh no, I need actually postcard. I need only postcard. Postcard. And now we do have a postcard here, and what we need in order to run Wasp.
8 points and
correct. So
point car.
let's do it. Copy binary k points into here. Binary in car here, and now we need to create the pod car, right?
Yes.
Module show wasp. So pseudo potentials are located in this directory. So I'm practicing the cat command for concatenation CAT from this directory. I'm hitting the tab PBE tab once again, and now it tells like 300 possibilities. Now the sequence of atoms is CHNOP. So I'm doing C pod car bigger pod car. Sequence CHNOP. H N O P. Yes?
May I have a question about the postcode that you are using here? For a certain type of atom, for instance, when you have carbon, oxygen, nitrogen, for instance, these three, the postcode for these three also is unique. I mean, it's universal postcode for each atom or no?
So if you use a directory without any labels, it will be universal. If you understand which speciality you need, then let me repeat this command quickly. So if I go into there are several options, like for, let's say, LAB PB. There is PB with explicit d electrons. There is a PB with explicit d electrons and relativistic effects. So if you need that, you need higher precision, and your calculations need additional specialty, you may take pod car from this additional directories with underscore labels. But if you are doing something simple and universal, just use the atomic element. Make sense?
Yes, thank you.
Okay. So what else do we need to run? We do need
Postcard.
No, we have postcard. We do need the shell script for running for submitting job. So I'm going to debug sh, and we can and definitely we need more resources. Okay, so first we will run it without any ionic steps, just single point, and it could be sufficient to run on the debug queue. But very soon, right today, you will need more resources, and you can put some larger number of longer time, and you may want to run optimization, and for optimization of this molecule it would be better to use this regular so this phospholipid is yet in the queue. In the debug jobs there is one manganese doped running for 8 minutes, and there are 2 jobs in the queue. So please explain me what is your plan for the rest of the project?
I'm not completely. I just want to see that, for example, phospholipids, when they are oxidized with hydrogen peroxide, they can allow many ions to transport within the membrane, but no, without any oxidation, if they are heated, they allow many ions to transport within the membrane. So I want to observe what's the difference when they are heated after being oxidized by hydrogen peroxide.
But since you're modeling only one monomer, what are you going to see after it hits? What is your expected outcome?
I'm confused about that.
So if it would be the complete membrane, like little fragment of membrane, we could try to explore how the foreign ion moves across.
Okay. So if I work on a polymer, right?
If you would use like several monomers connected to each other as they are created in the VMD.
Okay.
So
I can try that.
Yes, please do, and just in case, let's make a backup plan and set up heating job right away. I don't know what will be coming out of it. We need to discuss more the philosophy, but just in case, maybe it will show drastically changed pattern of motion after it is oxidized. So copy everything to the heap. CD heap cp binary in car heat into here in car, and 300 is realistic, but it is very boring. I suggest for educational purposes use larger temperatures. Okay, and then we do we can call it heat phospholipid. Heat 1000 Kelvin phospholipid. As batch. I have no idea why it takes. Okay, submitted job, but now we can do SQS. This number. So it does tell that it will start in 3 days, but it lies. Typically, it will start much earlier. But the standard style of working for computational chemists is do your other activities of the day and just log in a couple of times per day and look if job has completed, and then if needed process it. But we do not need to sit behind terminal and wait until it starts and runs. It can we can log in next day and see if it has been completed.
Okay.
And if you have a vision of different models, or put literally foreign ion nearby this strand, or maybe take not oxidized regular monomer and put many hydrogen peroxide molecules around, and then launch molecular dynamics and see the reaction, how this oxidation happening in real time. This could be also a possibility.
Yes.
So please, I think your main goal right now is to set up strategical thinking, and maybe we should exchange a couple of emails. But please email me as soon as you see any interaction is possible, or help is needed. My schedule is getting less busy towards the end of the semester. I will be watching for emails around the day and try to answer ASAP.
Thank you.
My pleasure. Do we need to discuss anything? Yes?
Yes, I had a question.
Please.
So for building a polymer, can you please guide me? How should I proceed? I'm a bit confused in that way. So how do I build up a polymer?
Okay. I think I did share a pre-made model that is already
Yes.
periodic, and you can just modify it. I think it would be the quickest. If you want to do everything from scratch, you create the model in VMD and then save it in the VMD allows to save model and then convert it into XYZ and set up periodic stuff. Let me show the directory where you can browse and maybe borrow something. There is a so I sent this directory, I placed this directory in your subdirectory, but there are several models you can download and inspect them. So those are heritage from project two years ago, and there are pre-made and pre-optimized models of the phospholipid bilayer. So if, since time is limited, it could be quicker than building it from scratch.
Thank you so much. This will be very helpful.
Okay, so you see where are the directories? Let me. Yes. I placed this little project dir. So in your directories there is a file dir, and it includes the link to this subdirectory. So
thank you.
Yeah, please feel free to borrow any model from there. Anything else we need to discuss with you today?
No, thank you.
Okay, my pleasure. Let's chat with Salim, and the next will be Yang Chao. Salim, are you online?
Yes, I'm here.
Okay. I'm going to go to your directory and see what is going on.
Yeah, I just ran, I made a mistake and I ran the partial charge, which is not spin polarized. I mean, yeah. In the incar, so I imported the wrong incar file. I imported the incar partial charge instead of the incar partial charge spin, which I just fixed right now, and EINT for the energy that I want to generate the partial charge ALLK files for. But well, I have a question on
Salim, can you please guide me? I have been visiting your directory in the past, but I'm scattering my attention to different things. Can you, if you see my screen, can you please prompt which directory should I go? Should I go to the flip?
So yes, it's directory.
Okay. So let me check.
Directory that's like
Let me check something. Spin flip. CD spin flip.
Yes, that's another directory.
Okay.
So that's the one that I just deleted everything and I just copy the proper input in car file.
Okay, I will inspect it later. Let me go just one step back.
Excuse me.
Yes?
May I leave for 20 minutes?
Oh, absolutely, absolutely.
I will come back.
Approximately. The plan is as follows. So Salim, Yang Chao,
Raju, I think.
Okay, and I do not see someone is
Gillian?
who?
I'm not sure what her name is. Another student, Gillian? I'm not sure.
No. Let me double check. Who is from your research group?
Yoke.
Huh?
Yoke and Yancho. Yoke and Yancho. We have two students from our group.
Yeah.
I think he's talking about Gwen.
No, Gwen. I think she decided to take it easy on the class. Just a second.
Our students attend. We have all of them.
I think that's all we have.
I apologize. I'm forgetting names. Lee.
Lee is Yoke, yeah.
Yes, Zhao Fan. Yes, and he's not connected now.
Yes, I'm here.
Huh? So here is the list. I will talk to Salim, Yang Chao, Zhao Fan. He will be connected, and to Amir, to Raju. If you need to leave for time, feel free. And I'm trying to connect. If there will be something important, I'll share the recording. Yes.
Can you please put me little bit earlier because this is the month of our holy month, so I had to leave early.
You need to leave earlier. Okay.
I just need 5 minutes. I don't need that much time.
Okay. If everyone okay, I'll put Raju right after Salim then.
Thank you, everybody.
Okay, my pleasure. Thank you. Oh, sorry, I mistyped Amir. But let's focus on the.
So inside that folder, let's called flip.
Okay, flip.
The regular.
Let's look for the in-car. N up down equals 3. Okay. More spin.
I think there is a mistake here.
You
I have a question about it.
Okay.
So the N up down, I'm not sure. I think it's N up down, not N up, and then there is a W between down.
Yes, yes. There shouldn't be W. Grep N up down. Let me check. Grep N up down out car. So it tells N up down -1, which is not correct. So yes. we need to make N up down equals 3. So
okay, makes sense. And then after that, for the second job, I'm going to run with the in-car from surcharge spin. Do I still end up down there, or just for this?
Okay. I understand your question, and I have a clear answer. I just need to formulate. So, when you run for the part charge, you are using the wave car inherited from single point or from the optimization. If the wave car was done with a mistake, then part charge will be done, will be computed also with mistake. So there is no reason to redo part charge before this n up down thing is fixed.
Yes, that makes sense. That makes sense.
So we can fix it right in this directory or open another subdirectory. Or do you think we need another subdirectory, or it is fine to fix it here?
Yeah, if I want to fix it here, postcard should be okay. Postcard is okay. K-point is okay. I just to change the in-car and delete everything.
Yes.
Else.
N up down.
Take some time to do it one by one.
Okay. So let's. Okay. Do you authorize me? You can do it yourself, or I can do it as batch core debug, right?
Yes.
Huh.
So you change the con.
I'm just doing it automatically all the time. But if you didn't make any optimization of dynamics, it's so you are the lucky one. Your job started immediately. So I don't know why, but it started. Okay. So fail the car. What? You're a very lucky one. Your job is complete. Almost complete. See? And look here, it shows magnetization equals 3.0. You see it?
Yes.
And if we go one directory back and we do this tail Aussie car, it shows magnetization equals 5. So what you set up in the n up down is converted into this magnetization. So now, after this, I don't know, I will move your spin, your states up into states up old, just in case if there were any valuable information.
But that one should be wrong, so I think it's not okay to remove it.
Okay, you can remove it. I just I'm a paranoid and I have a fear to remove any files. Who knows? Maybe. Yeah, maybe it was. You know, sometimes two mistakes compensate each other, and you get the right answer. So, grep minus after, let's say, 250 minus after uppercase 250, Fermi. No, we need more. We need like 600. Fermi from out car states up, and the same for states down. Now let's do VI states up. Maybe I didn't do the right thing.
That file is really huge though, but never, I don't know if there's an inductor film.
Oh, okay. It's fine. It's fine. So we are in the line 6.
Seems like we have less bands than before.
Sometimes there is a protocol. There is a protocol to automatically compute number of bands, so I wouldn't be worried about it. So in the lower right corner is 609. So delete 6, delete spin component 1. Now I'm going to 192 and I'm deleting everything, typing letter D, and then some big number like 1000, and then D once again. So states up is ready, and now I'm opening the VI states down. So it's about 800, or yes, so 800 lines need to be deleted. I'm going to the first line, typing D 800D, so deleted first 800 lines, then I'm typing DD script, right quit, opening it once again, going to the line 192, and then D 1000D, deleted. So now we have two files, states up and states down. Let's look states up, more states up. Let's look in the vicinity. So for states up, Homo and Lumo are 35 and 36. And for states down, 32 and 33. Does it make sense? It's different, right?
For the other one is 130. Yes.
Okay.
The other one 135, 135.
Okay. So now you can make density of states for this one, and your directory spin flip is where you wanted to do orbitals, right?
Yes.
Okay, copy wave car into spin flip, And let's just in case copy the CHG, and I'm not sure it is needed, but I'll better do it. Okay. CD to spin flip. And now let's do VI in. Oh, I have forgotten. Let's go back. CD. Let's measure the number of bands. Grep NVA out car. So number of bands 192, right? So spin flip, VI in car. One 92. Okay. -4. I would put a little less because to cover the larger range. And if it doesn't generate enough files, then we need to rerun it with different interval. Okay.
So
wait. Salim, I need to check something important. One directory up. Query. Okay, in both ways you used VASP gamma. Okay. So you were telling something.
Yes, I wanted to mention that in this incar file, we also, I mean, I see that you didn't remove down, but then it's still, it's not going to change anything if we keep it or remove it.
Okay, let's watch incar once again. I spin equals to n up down. I think everything is fine. We can run it. This this doesn't change anything, but I didn't think it changes. But query debug. Okay. SQS grep debug. So we have two jobs running. One CNT probably is by Yang Chao, and one phospholipid probably by Mahek. So now, Salim, we need to wait in the queue. So your main thing would be to compare, to make the density of states and later spectra with this ground state and spin flip. And I think it is a top thing to complete. But optionally, you can take both models and run heating and molecular dynamics for those and check how heating affects them. It is not primary goal, but it would be also interesting. So it's one thing, and another optional thing, you may request from me or approach Aaron Ford. So for both of these configurations, ground state with 5 unpaired electrons and excited state with 3 unpaired electrons, you may want to run so-called spin orbit coupling calculation. this will be more, how to say, modern, precise, accurate, and adequate calculation, but it is simple run, but it will be too many explanations. So just please keep it in mind and request from me if you want to. So you have primary thing, you basically will be done with calculations soon, and you need just to explore and explain for this 5 unpaired and 3 unpaired dose orbitals and spectra. And if you want 2 optional additions, molecular dynamics for both configurations and spin orbit coupling for both of configurations. Right now we do not have time because I need to focus on other projects, on other classmates. But if you are interested, please we can exchange emails or set up a Skype meeting in other time. This is not. It's not necessary for the class, but it will be really helpful if you want to convert it into publishable paper.
I believe I would want to
okay.
Is it something that has to do with the geometric property of, the octahedral property of the medians?
No. Spin orbit coupling. Spin orbit coupling is a thing that we do not have enough time in semester to show it, but it is a mechanism to describe how spin flipping occurs, to allow optical excitations with spin flip. And it is what actually happening in these manganese doped crystals.
Yes.
So right now you are exploring initial with 5 unpaired and final with 3 unpaired. And spin orbit coupling will show mechanism how spin is flipping by mixing alpha and beta electrons.
Oh, I see. Yeah, I read some papers saying that it's coming from the electrons from the ligands.
Mm-hmm.
Like they're donating the electrons, and then these electrons are having repulsion with the ones that are originally in the metal ion.
Mm-hmm.
And this is why the energies would be different, and then this difference I think is high,
mm-hmm.
and some of them would. This is how and then the 2 of them. This is what it's so far, and yeah, I'm still reading about this crystal
field
theory.
Ligand field theory, crystal field theory. Okay, Salim, do you have any urgent questions to me right now?
No, I don't.
Okay, yeah, thank you. Then let's complete our one-to-one session, and I will go to the next one, if you permit.
Thank you very much, Professor.
Okay, thank you. Raju? Let me go to your directory.
I have 3 questions for you.
Okay, so I'm listening. Just explain your question.
Because I'm not from the chemistry background, and I didn't take the course regarding crystallography. So when I'm editing the crystals, actually my C file, so for that you see it's very easy. I'm just deleting an atom. So for the interstitial, what I have to do, I have to put an extra atom, am I right? So when I'm going to do that, when I tried all the software, Avogadro is very bad to do that. JMOL is also very bad. So the software that is helping me is Vista and Gaussian. Better option.
Okay.
So what I did in the base stuff, I calculate the position, so I input the coordinate, and automatically the atom pops up. But the problem is the atom is showing bond with other atoms. So is there any problem?
Absolutely no. Absolutely no. So this bonds that are showing in the software, they are just using some cut-off distance. So if two atoms are placed closer than some threshold distance, the software draws a line, but it doesn't mean anything. And optimization will fix it. Optimization will fix it. Do not worry about it.
Yes, Dr. Dean. Thank you for this clarification. Because the bars don't have any bonds, they only calculate about regarding that coordinates.
Correct, exactly.
So another question, so I forgot the question. Can you please show me, Dr. Dimitri, how to find the DOS PDF from the states, because my states are more than 1,000. How to find it and how to format it in different files?
1,000 atoms and many electrons is not a problem. So please navigate me, which directory should I go to?
Is go to here and go to Linux.
Okay. Then
go to pure review.
Okay.
Yeah.
Okay. It's enough. It's enough. It's enough. Let me do something, and then I'll ask you.
I think the topic you just mentioned today at the beginning, this is very helpful for me, because from that point of view, I can hit my sample and can see whether it is in cubic phase or not.
Okay. You see what I am doing, right?
Yes. 2000.
Six 180. Do it. 680. Do it. What? So I am just parsing the states out of. So it's very small number of states, and D times D. So I do not understand what's the problem. You just parse latest list of orbitals from the outcar, and let's watch where the Fermi energy. So Fermi energy here is at 3 electron volt. The gap is about 5 electron volt, and we may try to explore it maybe from 0 to 10 or to 11. So grab Fermi outcar. and we need only the last one. And let me share the line I was using. Copy, and I will type it into the comment chat. Okay, so now let's do WC states bin address DOS normalized. Number of states 5,
Now
8.
I can do it. Thank you.
Okay. Fermi. And will you be able to repeat it for other models?
Yes.
Okay. And I'm just. Do you have more questions, Raju?
Not today.
Okay. Okay. Thank you. I'm just curious to look on the density of states for your model.
Yes.
SCP everything PDF into well, probably I will look on it in my free time because I need to make interview with others. So Raju, you confirm that you do not have any more questions right now.
No.
Okay.
Thank you. Thank you.
Okay.
I'll be leaving academically. See you then tomorrow.
Yeah. See you tomorrow, and send me an email if anything
Bye.
is needed. Bye.
Sure.
Yang Chao.
Yeah, yeah.
Oh, okay, let me go to your directory and check. Look at your files. Okay, which directory should I go to? Project CNT. Okay.
Yeah, yeah. This one.
Should I go to some other subdirectories?
Yeah, it's okay. For initial, 01 is for optimize the geometry.
Uh-huh.
For initial, 1000K is for 80.
Uh-huh. So I'm listening.
I just sent some my plan for this project to the chat room. As you can see.
Okay, I see you're typing something.
Yeah, project. Yeah.
So it is your plan. It is your strategic plan, right?
Yeah, it's my plan, but I'm not sure it's okay or not.
So orbitals, those orbitals and absorption spectrum are most important.
Okay.
And as soon as you have them ready, please copy paste them into Word document and send to me for discussion.
Okay. You mean the result?
Yeah, the results, and I want to have a look on them. If you create the heating molecular dynamics, it's also cool, but it is let's please complete your dose, absorption, and orbitals as soon as possible. We should talk one to one, maybe by Skype or just exchange by email, and then decide if it will be sufficient or you need more computations.
Okay. Yeah.
Do you have any practical challenges that you want me to that I can contribute solving?
For RDF, actually I just failed to create the file CR, but I will watching the video again after the class.
Okay.
Yeah.
So RDF for this project is not as important. It is secondary because there is only like a couple of chemical bonds. So RDF is more important if the crystal is melting or liquid is evaporating.
Okay.
So you can do it, but it is not primary goal for this project.
Okay.
Orbitals, not only HOMO LUMO, but few more would be really cool. And so just dose, absorption, and orbitals for initial and final is a minimum. If you want, if you're interested to do more, let me type it in the comment chat. Or I can just type it here in your directory. Make not directory vi options. So primary dose absorption orbitals for initial and final. Additional and optional. Optional heat and AD. Additional. So in the primary calculations, you are using I spin equals 1, or you are not specifying I spin. Spin equals 1, which is spinless. Additional, you can do for initial and final, do I spin equals 2 and n up, down equals 0, n up, down equals 1, and up down equals 2. So it and for each of them do those orbitals, those and orbitals, and maybe absorption if time allows. But absorption for spin polarized I was not covering in class. There is an additional challenge. But just exploring n up down could be very important, because on experiments for these systems, they often come into triplet configuration. So let me put here, so additional 1 and additional 2. Chop CNT and adsorbate into separate files. So make a file that contains only CNT and only this aniline. And then for each of them, do DOS and orbitals and make it spec.
Okay.
I think it would be very strong research, and if there is a chance that there will be some discoveries that may lead to a publication, I cannot guarantee, but it's truly interesting, and there are some opportunities. So why these options exist? Because when adsorbate and carbon nanotube connect to each other, their density of states and orbitals are not just summation of these two components. There are additional states on the interface, additional interfacial states. And if you use only CNT and only adsorbate molecule as a reference point, and then compare it to the combined system, then you can illustrate mechanism of formation of this interfacial state. So scientific novelty, mechanism of formation of interfacial state using stand-alone components as reference point. Make sense?
Yeah, makes sense.
Okay, so let me know escape, right quit. So it is here in your directory. Do you have more questions?
Not yet.
Okay. Okay, but I'm really interested in this project, and please do not hesitate. As soon as you have an even small minor question, feel free to email me immediately.
Yeah, sure. Yeah.
Okay, thank you. Then our one-to-one session is complete, and I will go to the next project. Zhaofan?
I'm here.
Okay, let's go to your. Let me go to your directory and check what is there.
Yeah, here is a trajectory called jet. In your case, yes, same thing, right?
More. Okay. So, which first, please tell me a little bit about your project. I know that you were talking before, but I was focusing on different things. So, if you just summarize, what are the goals of the project?
I feel like the primary goal is to look at the radial distribution function of different types of bonds, or the carbon, only carbon, or the only oxygen. Or even at different temperature, just as you said, at room temperature or well above the melting temperature, to see how the curve looks like.
Okay. Okay. Good. Then let's try doing it right now, so that we do not waste time, and then I will chat to Amir. So I am typing module show wasp because I cannot memorize this long link. Control C, Control V, and I'm doing position to XYZ PL of the cont car. Now I'm copying cont car let's do this one. Grep O cont car XYZ into cont car O.xyz. Now, what else do we have? Which elements?
Hydrogen and carbon.
Okay, so hydrogen is boring. I don't think anyone needs it, but carbon, yes, carbon. And here is nitrogen. I don't know, is it good for cellulose? If you need.
No, I don't think there should be any nitrogen here.
So you may double check your model and look wait, carbon and oxygen.
Yeah, and here is one question. I met an error before when I do the geometry optimization, probably due to the pole car, because the error is the pole car is not or is incompatible with the postcard. So I just change to another postcard and run again.
Okay, let me check. Grep PBE podcar CHNOS YS. You don't have sulfur.
Yes, no, don't have.
Podcar CHNO. So if it is the last one, it will not affect your thing, but it is a little strange why you have sulfur. There should be only compatible. If there are 4 elements CHNO in the podcar, there should be CHNO. Okay. So I did grab this oxygen and carbon into this reduced files. Now let's vi cont car oxygen. So it doesn't have the number of atoms. So we need to do grep WC cont car oxygen XYZ 20 atoms. Vi cont car oxygen XYZ I 20 empty. The same for.
Hi, Dr. Kelly. Could you copy the command to the chat room? How to extract the oxygen information to the XYZ format?
Yes. Sure.
Oh yeah. Okay, thank you.
And then I'm using this WC to count the number of atoms. Vi car oxygen. So I'm putting 20, and I'm counting number of carbons. Oh, I already did it. WC cont car carbons 68. Vi cont car carbons I 68. Escape, right quit. It's safer. I just do not want to contaminate any other files, so I'll call it RDF oxygen and RDF carbon, and then I copy cont car oxygen into RDF oxygen and RDF carbon. Now let's go to the RDF oxygen. I'm copying this into standardized name because the code will be reading for this one, and then I'm going to practice this vi input.rdf I.1. I think 5 will be sufficient, and then so let's look onto our records that you were doing before. So I'm doing this pair distribution, and if it will not work, I will change the libraries for the compiler and add additional lines in the cont car. It does work right away. Okay. It does work right away. ls-lt. So it has this CR file. Now I'm doing GNU plot binary GNU prog rdf4. So it creates this rdf.ps, and I'm doing ps to pdf right rdf.ps. And now I'm just transferring to the I'm creating the same directory, so it will be easier. Directory wd and Ctrl-C scp.pdf. And I can look on the local computer there's a typo, 2 periods. Yes. Oh, okay, it should be also column in here. file, open. I'll just want to see. Okay, so the first oxygen bond is at 2 point. Yes. And for if you do the same for carbon-carbon, it will be very different. It would be first peak will be around 1.5, right?
Right.
Okay. Are there more questions for your project?
Yes.
Okay.
I'm just curious how to check the geometry is done or not, or I can say how to make sure the system get into the local energy minimum.
Okay. So
because in my simulation, I shown almost 300 in the ASW.
I understand.
300.
I understand. So I will tell you in a minute. So I'm looking through this Sloom. When the jobs are started, they are creating this Slurm and then the job ID file, and at the very end of this file you see this reached required accuracy, stopped structure energy minimization. So this is a signature that it is true optimal geometry.
Okay, so no matter what the ASW I choose, it will stop automatically.
Right.
As long as it agrees.
Yes.
Okay.
Make sense?
What if NSW is not large enough technically?
Then you need to then you need to copy cont_car into postcar and continue optimization.
Okay, so having this signature means that we reach the global minimum of PES.
Your analysis, your thinking is very deep. There is no guarantee that it is global. It's highly likely global, but maybe one of the local. For if the system may have a lot of isomers, amorphous isomers, and then in order to if there are several local minima with the same energy, one needs to hit and re-optimize and then explore this isomers. The guarantee of a global minimum is only if it is either single molecule or highly symmetric crystal. But for polymers, there is a very high chance of amorphization. So you are asking a deep scientific question that is not always have an ambiguous answer.
Okay.
Okay. Also, we do the geometry optimization first, and then heating and molecular dynamics. So for the geometry optimization, it's around under 0 K or the room temperature. Dr. Kelvin.
It is quicker if you start beginning temperature is the same as final. It means you place your model on a stove. if the model is small, if you really need to minimize fluctuations, one may hit it slowly, but for most of our simulations, we do not need such a delicate approach. So if you put beginning and final temperature the same, it's very appropriate approach.
Okay.
More questions for your project?
Not today. Thank you very much.
Okay, thank you very much. Amir, let's focus on your project, and if we get disconnected, let's reconnect through Skype. Here is my number, Dmitry.s.
Sure.
Okay, so I will go to your directory.
PWD or this is project.
Okay.
Yes, this is.
Which directory should I go, or should I stay right here?
First, here this is equilibrium.
Okay.
That define an independent for that, but I have also heating and molecular dynamics. But heating is still running, and also molecular dynamic I didn't use the heating counterpart, so it's not a reliable one.
Okay, let me quickly look onto your okay, 6 sulfurs makes sense. Tail the car.
What can you understand from the Aussie car, Dr. Kirin? Can you also let me know?
Yes, yes. So when you
sorry for asking.
No. Thank you for asking the right question. I'm happy. So when VASP is running, it dumps output into this Aussie car about electronic and ionic steps. So I do see how many ionic steps are completed, and I see that it didn't finish. It didn't stop at the. Probably the job was terminated because of lack of time in the queue. So you likely submitted it to the debug queue, and after 40 minutes were finished, see, it stopped at the iteration, which is not good. It should stop at the how to say. It should write that job terminated because job completed because of reached required.
That right?
Huh?
There were a limited wall time for that.
Exactly. So feel free. Let me do cp query debug into query regular. Vi query regular. So replace the word debug into word regular. Regular. And you can put some much bigger numbers so that it would fit everything. For regular, it will not go into running immediately, but you need to wait about a day. But yeah, but it will, you can run much longer things. Of course, I prefer debug because I'm very impatient by personality, but for longer jobs it will not help. So and cp concar cp concar postcar, and I think we need to rerun
postcard file, right?
I did override. I did override from Concar into Postcar because Concar is the latest updated geometry.
I understand. Okay. Well,
And
I have original one in the, I think in the photo. It's okay.
Okay. Okay.
It's raw.
And also module show wasp. X dot XYZ. So you can download and watch it. So if you see that some bonds are broken, it will be a bad sign. So one may want to explore that the geometry is not getting distorted. So this movie is not actual movie of molecular dynamics. It's just visualization of the optimization steps. But
snapshot, right?
It's snapshots of optimization steps.
So it's noisy. It just have the coordinates, so it's not
Yes.
multiple snapshots.
No. Let's look here. So it will be it's same format as a movie. Let's transfer it to the photon and watch on it. Movie 5 already here. I wasn't okay. PW. Sync. I'm just sending all files and PWD copy what's the name of your polymer?
That was conjugated polymer chemical.
Okay. Let's call it.
We have here, I think we put it in project CP, if I'm not wrong, that again.
Yes, but later on you will need to have exact chemical name.
Okay.
Specific name. It will be like polythiophene, blah blah blah, something.
Yeah, I know.
I'm going to move here only the .xyz into here. So, and I'm doing So we do have periodicity along Z, and if you look these optimization steps, there are no drastic changes. It's just little updates. And
So because it's not optimized well.
Yeah.
How do you make?
But it's you see it's a little buckled in this. It's going down and up, which means it is a little bit compressed along Z. So if we would have time, I would stretch it a little bit along Z direction. But right now it will be small error, about 1%. So I wouldn't worry about too much. So it looks
Okay.
It looks reasonable. Corey, do you have? So I would rerun vi impar. I would rerun few more steps in debug queue and making the po team bigger and bigger. Did you try to make density of states?
Not yet. I will do that. So first I will try to run using the regular queue for the regular, and so the density of a state here should be after optimization, basically before going to
Yes. So ideally it should be after optimization, but it's not a big amount of labor. You can do it before optimization and after optimization once again, just as a backup.
okay, sure.
Just to explore how it looks like. So I'm looking on the gap of the system is about 1 electron volt, and one may check if this agrees with experiment. So for this model, it's absolutely interesting and important to, after making density of states, to run for spectrum and orbitals. So like not only HOMO LUMO but few orbitals nearby. And I anticipate that there will be some scientific novelty in this. So the HOMO will be localized on this sulfur and nearby carbons, and LUMO likely will be localized on these units with nitrogen and oxygen. And if one will go to higher orbitals, HOMO minus, I don't know, 5 and LUMO plus 5, it will be, charge density will be delocalized along the whole strand. And this information could be important for exploring conductivity properties. So as soon as you complete optimization, it would be really interesting and important part.
Sure, I will work on it after, I think, Thursday or Friday. I will try to keep working on it continuously. Actually, we are still working on it in the microdynamic part.
Very good, very good.
I hope I'm not good in quantum yet, but I hope to learn something more and from you also. I'm not sure what's your opinion on it.
I'm very optimistic, and your force field or multi-scale molecular dynamics is complementary to ab initio. It's really healthy approach if one does both. So ab initio can get some micro structure, but it cannot go into bigger than certain size. And if one does both, it will be full picture.
Yeah, that would be great. I'm really interested in this project for sure. I will try to do my best on this.
Okay. If you have some papers about this molecule, you can share them with me, and I may like just adjust plans or prepare to help more.
Sure, I will. I have some experimental jobs.
Mm-hmm.
Also, we published this paper
Mm-hmm.
in Advanced Functional Material Journal.
Mm-hmm.
We have also some collaborators from experimental part. So I will also share that paper with you as soon as it gets online. But as some references, I will share the experimental paper that already are published from that group with you.
Very good, very good. Thank you. So, do you see any specific help I can, any specific contribution I can do right now? You have.
I appreciate your help for providing the model. I will, as you mentioned, I will try to run the optimization again and go from the density of a state, also a spectral and orbital as the next step.
Okay.
And I will stay in touch with you through the email or
super.
else.
Very good. Any other questions for today's session?
No, I have still some problem with the initial model. How to define, for instance, for this model, how to define the periodic unit. It's my major concern, but I will ask you maybe later. So I know you're so tired right now.
No, I'm happy. It's not a. If you want to keep asking, I'm here for you. So do not worry. So your question is how to set up.
Here for this model, periodic model is each. Each monomer could be a periodic unit.
So
here we have a diamond, right? We have two monomers.
Yes, we have two monomers, and if you would have only one monomer and periodically reproduce it, then the measure dihedral angle between this 253, 33, 30, and 254. So this dihedral angle would be 0. So the sulfur atoms will be on the same side, and they would repel each other, and it would create as a little resistivity at this point. So to have the optimal conjugation, they should be around 180. This dihedral angle should be around 180. So it is what we did for the. So I think it's quite. It shows 172, and for the most practical problematic thing is to establish the bond between atoms on the different sides of the polymer. So when one places it in X and Y plane, these atoms that we need to connect should have approximately the same coordinate. So 61 and 70 should be approximately at the same X and Y coordinates, so that upon setting up periodicity they will connect. And then when one practices this Tink to VASP, one needs to add amount of vacuum along Z direction corresponding to the distance between two carbon atoms, so about 1.4. And for the directions that do not have periodicity, you just add something like 7, 8 angstroms of vacuum to avoid interaction between images. Does it answer your question?
Yes, it's a little complicated for me, but yeah, that provides some insight for me.
Okay. Okay, if you need to build another model, we can do it together. I know it comes with practice. So you prepare first 20 models and then it becomes natural.
Sorry, I didn't get.
I'm joking. You prepare first 20 models and then it becomes easy and natural.
Okay. So I have another question basically for our paper. We investigate several side chain length and study how they influence, for instance, the glass transition. So you think here after this, we just need to consider constant chain length, or after doing this model, we can also check longer chain length, or I don't know, what's your opinion?
So for in the remaining time for the class, I do not think we please call me Skype if you get disconnected.